All right. So here are all the questions we have on section 5.6. So we're going to go through these problems, every one of them, and we're going to, our job, remember our job is to not feverishly write down everything Mr. Anier writes. It's to pay attention, make sure we understand, and look for things that are common, right? That's what math is all about. It's like, oh, wait a minute. The last time we had a problem that looked like that, we did this, and we're doing the same thing again. Oh, okay. So we're going to start with number 11, right? We're going to start with number, that's the smallest number on the list. So we're going to start with number 11. Now, number 11 says we have 1/2 log base 3 of x equals 2 log base 3 of 2. All right. Now, we have an equation and it has logs. When we have an equation with logs, our strategy is to eliminate the logs. And this property has a circle around it because we use it a lot. That's why I put a circle around it. It says if we have a log that is equal to a log, and they both have the same base. The a didn't make it in the circle, but the base a, they both have the same base. Well, we have the same base. Then if they're equal, their arguments have to be equal. The thing we're taking the log of, we call that an argument. The arguments have to be the same. However, there's one important step. There's no number in front of this log. There's no number in front of this log. They don't have a coefficient. Their coefficient is 1. But in our problem, our coefficients aren't 1. So we're going to have to fix that before we can use the log property. Before we can use the log property. So our coefficients must be 1. Well, lucky for us, we have a log property that says we can move this up here. Right? We have this property right here that says if you have a coefficient out in front, you can make the coefficient a power. So we can rewrite this as log base 3 of x to the 1/2 equals log base 3 of 2 squared. We can move the coefficients. We have to move them first, okay? You must move them first before you can apply the property. Now we have log base 3 equals log base 3. The coefficient here is a 1. The coefficient here is a 1. So the property actually applies. The property applies. So now this can be rewritten as x to the 1/2 equals 4. Now we know what that says. That says whose square root equals 4, because x to the 1/2 means square root, right? X to the 1/2 means square root. Whose square root equals 4. But if you don't like that, if you don't like that approach, you could square this side. You could square this side. Power to a power we multiply, so we get x. Over here we get 16, and that's our answer. Now we got to check it. Remember, we always have to check to make sure it's going to work. So I plug in 16. That would be log of 16. Log of 16 is defined. The graph of the log, we'll just jot it right here, and then we'll just leave it up here. The graph of the log goes like this, right? The domain is a set of x such that x is greater than 0. Or if you like interval notation, open at 0, open at infinity. So when I put 16 in here, it turns out to be positive. So I'm okay. So this is my answer to number 11. So when I have two logs, I'm going to eliminate them, but they have to have a 1 in front of them before we can eliminate them. All right, so let's take a look at 13. 13 is 3 log base 2 of x equals negative log base 2 of 27. All right, once again, we have a log equal a log and the bases match. But we have coefficients. Over here we have a 3. Over here we actually have a negative 1. We actually have a negative 1. And we have to get rid of those. You're not allowed to have a negative sign. The property doesn't have a negative sign. So you can't have a negative sign. So this 3 has to go up here. This negative 1 has to go up here. We have to move them out of the way. We're going to use this property right here a lot when we solve equations. So now what do we have? We have log base 2 of x cubed equals log base 2 of 27 to the negative 1. See, now they have coefficients of 1. There's a 1 here, and there's a 1 there. And when that happens, I can use this circle property. But until then, I cannot use that property. Part of where we mess things up with logs is we try to use the properties when they don't apply. And then we end up with bad answers. So we can drop the log, right? The logs go away, and we get x cubed equals 27 to the negative 1. Now we know what that is. That's 1 over 27. So we ask ourselves, what do I cube to get 1 over 27? Or we take the cube root of both sides. Over here, we're going to get x. Over here, we're going to get the cube root of 1 over 27. The cube root of 1 is 1. The cube root of 27 is 3. Now we have to check our answer. Got to check our answer. When I put 1/3 here, I'm taking the log of a positive. So this works. So my answer is 1/3. I can't check it by plugging it in and working it out. Right? I can't do that. So when I say we're checking it, I mean we're checking it to make sure we're in the domain. Okay. So that's number 11. That's number 13. The next one on the list is 15. All right, 15 is right here. So we'll do 15. We'll put it right here. Okay. So 15 is 3 log base 2 of x minus 1 plus log base 2 of 4 equals 5. So problem 15 is different. It's different, right? Remember I said at the beginning, we're going to look for patterns. This one had a log on both sides. This one had a log on both sides. So we know what to do if there's a log on both sides. I get a coefficient of 1. I get a coefficient of 1. I make the log go away. I use this property. What do I do if there's not a log on both sides? Well, don't overthink it. Don't go, well, I'm going to move this log over there. No, that's not going to help. That's not going to help because you're still going to have a 5. 5 doesn't have a log. So we need a new strategy. Okay, we need a new strategy. And our strategy is going to be, we want to put these logs together. We want to combine them. Now we have a log property right here, right? This one right here. It says if you have a log plus a log, you can make it one log. If you have a log plus another log, like we do right here, you can turn that into one log. And that's going to be our strategy. If you don't have a log on this side, you want to reduce it to one log, just one. So you want to do a combination. You want to put them together. We practiced that in the homework in 5.5. It said, take these, combine them as a single logarithm. That wasn't just an exercise in section 5.5. We needed that so we could do the homework problems in 5.6. However, right? However, there's a coefficient here. There's no coefficient here. There's no coefficient here. You can't have a coefficient. Before you do the property, you have to make this go away. And the way we make it go away is the same thing we've already done twice. We put it up here. Now we're going to rewrite this. Now we can put those logs together. Okay, now we can put them together because we have a 1 and we have a 1. So this looks like this. Because the log property says you multiply the arguments together. You multiply. So I took the 4 and I multiplied by x minus 1 cubed. But now I have a log equals a number. That's okay. I got a property right here that fixes that. This property says if you have a log that equals a number, you can make the log go away. Look, over here, there's no log. We made the log go away. This 2 is going to come over here and lift up this 5. Right? That's what happened. This a came over here and lifted up this y. See? A lifted up the y. So I have 4. I have x minus 1 cubed. And I have 2 to the 5th. Now we all know what 2 to the 5th is. 2 to the 5th is 32. Divide over here by 4. Divide over here by 4. X minus 1 cubed equals 8. Take the cube root of both sides. Move over the 1. Now remember, we have to check. We have to check. We can't go, oh, it's positive, it's good. No, no, that's not good enough. What happens if up here, somewhere in this problem, it says x minus 5? What happens if it says that? When I plug in 3 and it says x minus 5, that becomes 3 minus 5, that's negative 2. So we would say that doesn't work. So I've got to check it. Even though it's positive, I have to check it. Don't get in the habit of going, oh, it's positive, it has to work. No, you must check it. So when I plug in 3 up here, I get 3 minus 1. 3 minus 1 is 2. 2 is positive, so this is my answer. So it works. Okay, it works. So this problem was different. That's why I picked a different color. The pink problem was different. We didn't have a log on both sides. We had a number on this side. So I got one log and I made it go away using my definition. Didn't even use a property. I just used my definition of logs. So if we have a number, this is how we're going to do the problem. So I'll leave number 15 right here. I'm going to do number 17 now, right? 17 is the next one on the list. So we'll do number 17. We'll do it right here. And we'll look to see how 17 may or may not be similar to 15, right? That's our job. That's how we learn. We look for similarities between things, right? So let's look at 17. Okay, let's look at 17. So as we write them down, we think about it, right? We think, oh, there's a log on both sides. Okay, there's a log on both sides. Oh, this one doesn't have a log on both sides. Okay, I know what to do there. That's what we do, right? We don't just go, So on 17, we get log of x. So they don't put a base. So it means base 10, right? It means base 10 plus log of x plus 15 equals 2. So we have this. We don't have a log over there. So we're going to want to put our logs together, right? We don't have a log. And when we don't have a log, we want to put our logs together. So we want to get our logs together. Look, they were very nice, right? This is a 1, and this is a 1. We don't have to raise anybody to a power or anything. It's already set up for us to put them together. It's already there. We're just going to put them together. So I get log, and I get x times x plus 15 equals 2. Because that's what my property says. If I have a log plus a log, I multiply the arguments. Right? I multiply the arguments. Sorry. So we have log, and we have x squared plus 15x equals 2. Now, he's trying to trick us. He's trying to trick us. We got to make the log go away, right? We got to make it go away. But we have to, you and I, we got to remember there's a 10 there. Right? They don't write down the base 10 though. So we have to remember that all by ourselves. We have to remember that. If it's blank, it's base 10. So this picks up this. And I get x squared plus 15x equals 10 squared, which is 100. So I've got x squared plus 15x minus 100 equals 0. Well, now we're in algebra 1. Now we're factoring, right? We need two numbers that multiply by 100 to 100 that differ by 15. So that's going to be 20 times 5, right? 20 times 5. So we're going to get x plus 20 times x minus 5 equals 0. That gets me x plus 20 equals 0, or x minus 5 equals 0. That gets me x equals negative 20, or x equals 5. Now, we don't just throw this away because it's negative. We check to see if it works. There's going to be problems out there where the negative ones work. They're rare. Yes, they're rare. But we don't want to just miss them. So I take negative 20 and I plug it in right here. That would be log of a negative. Okay, I can't do that. I can't take the log of a negative. So this goes away. When I plug in 5, I put a 5 there. That would work. When I put a 5 there, 5 plus 15 is 20. That's also positive. So this is my answer. So this problem looked like this problem. We had logs on one side, a number on the other. We put our logs together, and then we made them go away using the definition. So those two problems had the same steps, right? The same steps in their solution strategy. So let's look at problem 19, right? We'll leave that one up there. We'll come over here and we'll look at 19. We'll take a look and see what 19 asks us to do. Now, maybe 19 is the same as 15 and 17. But maybe in problem 19, he changes it up. We don't know until we write it down. We don't know, right? We don't know what his intentions are. So we write down problem 19. Log 2x plus 1 equals, okay, so there's not two logs over here, right? There's not two logs. Equals 1 plus, he put a log over there, right? Put a log over there. He put a log over here. So it's different than this problem. Over here, the two logs were on this side, the number was over here. The number's still there. We still have a number on the right-hand side. But now we have a log over here with the number. Now we can't put those together, right? We can't put those together. That's not a log. We can't put them together. But we could put this log with that log. We could make it look like problem 17. We could take the log of 2x plus 1, leave it right there. Move this one over here. Now, it is a minus, but we know what to do with that. Now we have a strategy, right? Now we're ready. Now we know these two can combine. A different rule this time. Different rule. We're going to use this rule. Log minus a log. Right? Log minus a log. Now we check, right? We always check. What's my number here? 1. Good job. What's my number here? 1. Okay, I'm good. I can do it, right? We're not going to be the kid on the test that's going to have a 2 out here and it's going to combine these two logs. We're not going to be that kid. That's not us. It's not who we are, right? We're the kid that goes, oh, and it's got a 2. I got to put it up here, right? The first two problems we did, problems, what were they? 11 and 13. We had to do that. But on these problems, he hasn't done that to us. He's been nice. He's been nice. Now, what do I have here? I have log. Now I have to divide. I got to divide. So that's my property. I divide. Now we know what to do, right? If you have one log, use the definition. Use the definition. If you have one log, you use the definition. So I'm going to take the 10 that's right there that he did not write down because he's trying to trick us. I'm going to take the 10. It's going to lift up the 1. Okay, now we're back in algebra 2 or algebra 1. We know how to solve that. You multiply both sides by x minus 2. These cancel. You get 2x plus 1 equals 10x minus 20. You bring the 2x over here, you get 8x. You take the minus 20 over here and you get 21. So we get x equals 21 divided by 8. Now we check to see if that works. right? We can't check to see if it works by plugging in and getting the numbers to equal. Remember, we check to see if it works by seeing if it's in the domain, right? Is it in the domain? So I take 21 over 8. 21 over 8 times 2 is positive. 21 over 8 times 2 plus 1, positive. So that's okay there. Over here, I have 21 over 8 minus 2. Ooh. Well, 2 is 16 over 8. Common denominator. Still positive, right? That turns out to be 5 divided by 8. Still positive. So this works. So this is my answer. See, these are kind of fun. I mean, they're kind of fun. You've done a lot of math. You've done a lot of homework. There's been a lot of nights where you've been sitting in your room, in your kitchen, in your living room, in your office, in your den. There's been a lot of nights where you've been sitting down with a pencil and a piece of paper working on math homework. I mean, all the way back to 5th and 6th grade. It's paying off now. Look what we're doing. That's some good stuff right there. None of us would choose this. Right? I mean, if our fairy godmother came and said, hey, I'll give you one wish tonight. You can do anything you want. None of us are going to pick this. But we have to do it. And so we might as well appreciate it. It's like, wow, that's some pretty heavy stuff there I'm doing. Should be proud of myself. Yeah, you should be proud of yourself. You should. Give yourself credit. Give yourself credit. You deserve credit. And unfortunately, in the real world out there that you're going to go to as an adult, most of the time, you have to be pretty much satisfied with credit from yourself. Rarely do other people come around and give you credit. When you're a student, it happens all the time. We're like, hey, good job. You got 100 on the test. Way to go. You got 97. Good job. Somebody writes on a question on your test. Excellent answer. You get credit all the time. Right? I'm going to go to the eye doctor today. I'm not going to get credit. He's just going to go, which is clearer, 1 or 2? And for all of us who've been to the eye doctor, we know how much we hate this. Because they always say, which is clearer, 1 or 2? And then we choose 1, right? Because you can see it better. You're like, oh, 1's clear, like 1. And then they go, okay, now 3 or 4? And you're like, oh, 4. I can see 4 way better. I can see 4 way better. And he goes, okay, now tell me 1 or 2. And you can't tell the difference at all. And then you're like, give me 1 again. They give you 1 again. And then they're like, give me 2 again. And I'm like, give me 2 again. He's like, which one's clear? And you're like, I can't tell. They're both good. For those of you who have never been to an eye doctor, you haven't had to go through that yet. For those of us who've been to an eye doctor, we know it all comes down to that. And then we sit there and we all do the same thing, just to make sure everybody understands. We all do the same thing. We eventually guess, right? That's what we do. Which is clear, 1 or 2? 2. And then you sell it, right? You sell it home. You're like, 2. No, are you sure? Yes, 2. You want to check again? No, I'm going to go with 2. So for those of you who've been to the eye doctor and had that happen and then you're not sure, none of us are. Don't worry. I think they know that we're not sure. I think they do it just to the point where they know we can't tell the difference, and then they laugh about it after we leave. I think that's what happens, but I don't have friends who are eye doctors, so I can't ask. All right, so what are we doing in 25? Right, that's our next problem. Next one, we did 19, right? Nobody asked for 21, and nobody asked for 23, so we're going to do 25. So we look at 25. 25 is, it's a natural log this time, less writing, right? Natural log of x, less writing, plus the natural log of x plus 2 equals 4. Okay, so we've done this problem already. Right? We did one just like this, just like it. What do I mean? I mean, we had a log, and we had a log, and we had a number. Of course, it wasn't this problem. But our job is to go, I've seen it. I've seen it. There's a 1 here. There's a 1 here. So I can put these together. So I'm going to write this as ln x times x plus 2 equals 4, right? Because that's what my property says. Log plus log, put them together. That's my property. That's why we have to know the properties really, really well, so we don't think, wonder what I do here. We look at them and go, oh, I got a property for that. Like when we're driving and a car jumps out in front of us as we're going down the road, we don't want to sit there and think, oh, I wonder what I do here. You got a rule for that. You slam on the brakes, you swerve. Right? But if all you're going to do is think about it, well, then you're probably going to crash. And you may still crash the other way, but at least you're trying to get out of the way. So we have to know these. Now, what happens if we have a log and a number? Okay, well, there's a power right there. I know I called it a power, but I mean, it's really a base. I apologize. It's a base. There's a base right there. And we know what happens. This thing goes over here and power lifts that. And we get this. This is what we get. See, this is why it's number 19, because it turns out to be an ugly number. So we get this. This is what we get. Okay, sorry, this is why it's number 25, right? Not 19, it's number 25. Now, what do we get now? Now we get this. Now what do I do, Mr. A? Well, you factor. Same thing you've always done. This is a number, right? You can ask your calculator for e to the 4th. We don't, because we don't have calculators on the test. So if we on the test write down a decimal here, Mr. Rainier is going to know we're cheating. We factor it. Now, I agree. I don't know how to factor it either. Like this, I don't know how to factor it like this. I don't know what that looks like. I mean, x goes here, x goes here. Minus. Somebody gets a minus, but that's a plus. So somebody gets a plus, right? Because that's how that works. It's a parabola. It opens up because that's 1 positive. It opens up. We can find the vertex, right? We know how to find the vertex. X equals negative b over 2a. That's going to be negative 2, right? Negative b, negative 2 over 2 times 1 is 2, negative 1. We know where the vertex is. We know all of those, but that's not what they want. We want the x-intercepts. Right? We want the x-intercepts. That's the solutions, the x-intercepts. So how are we going to find? We're going to use the quadratic formula. We can sit here and say we don't want to, but it's not going to change anything. We're going to use the quadratic formula. We're going to say x is equal to negative b plus or minus the square root b squared minus 4 times a times c. All over 2 times a. Now, I don't like it either, but that's the answer, right? That's what we're here for, is to find the answer, not to say, oh, all the answers have to be nice numbers. No, that's not true. So what do we get? We get negative 2 plus or minus the square root. We have 4, right? And we have plus 4e to the 4th. Now we can factor a 4 out of that. And we can all take the 4 out of the radical. So now we know why this one's number 25. It's number 25 because this part turns out to be less pretty, right? That's why they made it number 25. Now, this 2 cancels these. And we get -1 plus or minus the square root of 1 plus e to the 4th. Well, we got to check, right? We got 2 answers here. Right? We have 2 answers, right? Don't we have 2 answers? We have -1 plus the square root. And we have -1 minus the square root. So this one's negative. Look, -1, negative square root. That one's negative. If we put it right there, we're going to be in trouble. This one goes away. This is actually a positive number. You all know this is positive. If I offered you $1,000 and you thought about it long enough to want, because you want $1,000, you would figure out why this is positive. The square root of 1 is 1, right? Square root of 1 is 1. We're all okay with that? So this number right here is bigger than 1. Because it's 1 plus e to the 4th. Now, I don't know what e to the 4th is either. But that number is bigger than 1. So when you take the square root of a number bigger than 1, you get a number bigger than 1. So when I add it to the -1, I end up with a positive. Because this thing's bigger than 1. So when I add it to -1, I end up greater than 0. So this one works. You can all do that thinking. Right? If you're motivated enough, you could have all figured that out. Right. So this one was number 25 because he thought he would throw something fun in there for us, like the quadratic formula. Right? Michael was like, hey, we haven't seen the quadratic formula in a while. Let's do a quadratic formula problem. And I'll make it e to the 4th. So I don't know. Michael stubbed his toe that day and wasn't feeling very well. His wife left him. Who knows what was going on? He was in a bad mood. He couldn't get the baggie to seal when he was trying to put his lunch away because, you know, he was trying to do the red and green the blue and the yellow make green, and he couldn't get it to work. He was just in a bad mood. I mean, you know, but things happen. He made his smoothie in the morning, but he forgot to put the lid on the blender before he turned it on, made a mess all over the kitchen. You know, things happen to us. So he gave us this problem. Okay, so he gave us this problem. We all know the quadratic formula, right? There's an Algebra 2 teacher out there that knows us better than Mr. Rainier does because we spent a whole year with him last year. And that Algebra 2 teacher knows you know the quadratic formula. Right? If I called them on the phone and said, hey, what about so-and-so? Do they know? Oh, yeah, they know the quadratic formula, Mr. Rainier. They're amazing at the quadratic formula. Again, fairy godmother asks me what I want to do, and I have one wish. I'm not going to pick that. Right? None of us are going to pick that. One of us, maybe 2 of us, may think, I want 100 on the test. Now, the rest is like, I ain't wasting a fairy godmother wish on 100 on the test. Okay, I agree. But if we study hard enough, we can all get 100 on the test, right? We don't even need the fairy godmother wish. All right, so that was 25. What about 27? Right? What are we doing in 27? Well, we write it down. And we think to ourselves, I've seen this before. I've done a problem just like this one. It has 2 logs and has a number. 2 logs and a number. We know what to do. He didn't put a number there other than 1. He didn't put a number there other than 1. So that's really nice, right? So now we get suspicious because we're honor students and we think, right? That's what we do. We think, we're like, why is this number 27? I mean, we already know this 3 is going to lift up that 2, and that's going to make a 9. That's better than e to the 4th. What's he doing to us here? So now we're suspicious, right? That's how we are. We're suspicious. We've seen this problem before. We're like, okay, it can't be this good. I mean, we're suspicious. Something's going to go wrong here sooner or later. I mean, why did he put this problem down here? Okay, that doesn't factor, right? That doesn't factor. And we can't find two numbers multiplied together gives 5, differ by 5. That doesn't work. But we can do the quadratic formula, right? We can do the quadratic. X equals negative b plus or minus the square root b squared, right? B squared minus 4 times a times c all over 2 times a. Negative 5 plus or minus, that's 25. Pardon me, that's 20. That's 25. That's 20. That's 45. That's negative 5 plus or minus 3 root 5 over 2. Now that gives me two answers. This one's negative. I mean, that's a negative, that's a negative, that's a positive. This one's negative. And if I put a negative right there, oh goodness, I'm adding 1. Maybe 1's bigger than this. Maybe it works. It could work. I mean, if this equals negative a half, and I put negative a half right there, negative half plus 1 is positive a half. That's going to work. That's why this is number 27. We knew something about this problem is fishy. Well, why is it here? We've already done this a bunch of times. We got to figure out what this is. We got to figure out whether this is positive or negative and how big it is. And we don't have a calculator. So we got to think, right? That's why he made this problem weird. Look at this piece right here. That's negative 2.5, isn't it? I mean, on a number line, that's negative 2.5. That's 2.5. Now we're taking away more, right? We're taking away more, which means we're moving this way, right? When you take away more, you move left. How much do you get to add? How much do you get to add? You get to add 1. You're already at negative 2.5. Then you went left more. When you add 1, you're not positive. This doesn't work. What about over here, though? What about over here? Maybe this is negative. Or maybe this is negative, because we're already at negative 5. Then we add 3 root 5. We have to know what 3 root 5 is. We got to figure that out. Well, we're good at estimation, right? They taught us that in junior high. Junior high was all about estimation. Square root of 5. Well, we know the square root of 4 is 2. Right? 2. So the square root of 5 is bigger than 2. Bigger than 2. Now, square root of 9 is 3. 5 is really close to 4. So this isn't 2.9. It's not 2.8. It's really close to 4. 4 is 2. So this is like maybe 2.2. Maybe 2.2. What's 3 times 2.2? Because that's what it says, 3 times 2.2. 3 times 2.2 is 6.6. If I take away 5 from 6.6, I get 1.6. Because there's a minus 5 right there. If I divide by 2, I get 0.8. But it's positive. That works. This is why it's number 27. Okay. He wants us to think about it. Wants us to think. Not grab our calculator and plug in and get a decimal. We don't have a calculator. Theoretically, that's cheating. Not theoretically. Factually, that's cheating. So theoretically, we don't have the calculator. So the process was the same. The numbers just got a little worse. That's all that happened. The numbers got a little worse. So that was 27. 29, what's 29 going to be? I don't know. Let's look. Because we've done this now 3 or 4 times in a row, right? We've done this strategy 3 or 4 times in a row. Let's see what 29 says to this. Maybe it's the same strategy. We're getting pretty good at it. I mean, we've done it a bunch of times. We've done it so many times, we're kind of surprised he's still asking us to do it. I mean, we're kind of like, really? Another one of those? Okay. So we write down 29. And now we really get suspicious. It's got a minus, so we're not going to have to divide. Well, we don't like dividing. We're not big fans of dividing. And on top of that, it's got a 1/3. We don't like that right now. Oh, we're going to like it a lot in a second. We're going to like it a lot in a second. In a second, we're going to like this a lot. We're going to be thrilled about this 1/3. Right now, we're mad. 1/3? Seriously, dude? 1/3? That's what you're going to do, 1/3. Let's just do the problem and trust Michael. Okay, let's just trust Michael. We have log minus log. Everybody has a 1, so we can rewrite it like this. Now we know what happens. This power lifts this. We don't hate the 1/3 now. We don't hate the 1/3. Don't hate it anymore, do we? See, gotta trust Michael. Michael's not gonna mess with us. He likes us. Now we know how to solve this. right? We know how to solve this. We go like this. This is how we solve this. Okay, this is what we do. Don't do anything else. Okay, I'm going to write something next to this. Make sure in your notes you write no. I'm going to write no right here. Don't do this. Don't do this because it's wrong. Don't do that. You can't do that. You cannot do that. We've talked about this in class. You can't divide out variables. You don't know if x is 0 or not. If x is 0, you can't divide. So don't do that. Okay, don't do that. So we get this. This is what we work with. This one, this one. Now, what does this say? This says x squared plus x equals 3x squared minus 3x. Don't divide both sides by x and cancel it. Don't do that. You bring this, well, let's not do that. Let's bring this x squared over here. Let's bring this x over here. See, this is a quadratic. It's supposed to have two answers. If you cancel one of those out, you're not going to have two answers anymore. You're going to eliminate an answer. Don't do that. Now, we know what this is, right? Look what ended up being one of our answers. Now, we got to check. Got to check. Can you put 0 back here? No, no, no. You can't put 0 there. Why? 0 is not in the domain. If you put 0 here, you get 0 squared. If you put 0 here, you get 0. 0 squared plus 0 is 0. You can't take the log of 0. That's an open interval. So this is not an answer. What about this one? I don't know. Let's check. We got to check it. If you put 2 here, you get 4. If you put 2 here, you get 2. 4 plus 2, 6, positive. We're good. Better check this one. If you put 2 here, you get 4. If you put 2 here, you get negative 2. But 4 take away 2, positive 2. We're good. This is our answer. Okay. So Michael put this problem in the book to remind us not to do this. He hasn't pointed this out to us in a while, and so Michael writes a great book. He's like, well, we haven't really talked about that yet. It's been a while since we've talked about that in any homework problems. So I better give the teacher a chance to remind him of this. So I'll put a problem in there where the teacher has a chance to remind him of that. See, that's when you're writing a good book. All right, that's a good book. So what about 31? We've made it up to 31. Okay. So what's going on here? Well, we have too many logs to count. We have 4 logs. We went from 2 to 4 pretty quick. Look, we skipped 3 lines. And look at the base. Look at the base. A. Now, why is that a big deal, Mr. Ingram? Because we can't do the power lift step. We can't do this one where A comes over here and lifts this up. We're not going to get a number. We're going to get A to the third. I don't know what A to the third is. So maybe the base doesn't matter. Maybe that's why he made it A. Maybe he made it A because it doesn't make any difference. Because we know what to do, right? 1 in front, 1 in front, 1 in front, 1 in front. We always check that because we know Mr. Rainier is going to put a 2 in front of one of those just to screw us up. Because I'm going to put a 2 in front of one of those just to screw you up. No, I'm not going to put it in front of there to screw you up. I'm going to put it in front of there to make sure you know the rule. That's my job. Not write it like this so you can forget the rule and still get the question right. That's not my job. That's not my job. See, if this is me writing a test question, right? I'll put a 2 here and I'll put a 1/2 right there. Look how mean I am. Because now you're going to rewrite it like this. And then you're going to get this. And I didn't make the problem any harder than it was before, but I got to check to see if you knew the rule. But Michael didn't do that, right? Michael didn't do that. So what do we do? Why don't we make it 1 log? And we make this 1 log. And we know what to do with that. We have this rule. If your Algebra 1 teacher would have put that problem on your rational expressions test, you would have brought them a Christmas present. Your Algebra 1 test had way harder problems than that. I mean, look what happens. You cross multiply. My goodness, you're great. Oh, it's x minus 1 times x plus 3. And that's going to be x minus 2 times your x plus 6. And here's what's really amazing to me is some of you still don't realize how sweet this is. So I'll just keep going. This is x squared, and that's going to be that's going to get you your plus 2x. That's going to be your minus 3. And this one over here is going to be your x squared. That's going to be your 4x. That's going to be your minus 12. Oh my God, I got an x squared and I got an x. No, you don't. They cancel each other out. Look at that. You don't even have to factor. Oh yeah, it's pretty good now. I just got to bring this over here and I get a 2x. And I bring this over here. And, oh my God, I get a 9. It's not even. What am I going to do? I think you're going to write this. I mean, how nice is that? You didn't get, yeah, let's go to square, let's go to square. No, it doesn't have a square. Look at that, it's magically gone. Thank you, Michael. So why did he make it number 31? Because we're all going to panic when we see 4 logs. Oh my God, 4 logs. Oh, oh, oh. No, not ha ha. You don't have to sound like Pinocchio. You're fine. Just stick with your steps. All right, so what about the other half of the homework, right? What about all these other problems? Well, there aren't very many of the other problems now that we start looking at it, right? I mean, because we've already done this one. We've already done that one, we've done that one, we've done that one. We've done that one, we've done that one, we've done that one, we've done that one, we've done that one. We got a lot of them done. So we know what to do with logs. But what about the exponential question? Okay. All right. Well, we'll take a look and see what happens here. Maybe there's some kind of pattern to these problems, just like there was a pattern to the log problems. Maybe there's a pattern that's going to help us out. It'd be great if there is, right? It'd be great if there is. So let's take a look at these. Let's grab one of these. 31, 30, 30, 39. That's the first one was. So let's grab 39. It's right here. 5 times 2 to the 3x equals 8. Holy cow. Yeah, I don't know how to do that one either. I mean, I can't do it in my head. That's what I'm saying. So here's what we do, right? Whenever you have an equation and there's a variable in the exponent, you take the log of both sides. That's what you do. You're like, oh, they put the x up there. Okay. 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 Take the log of both sides. But before you do, you better have a coefficient of 1. You better have a coefficient of 1. We're going to use this rule right here. This rule, this one right here. And see that? That's a 1. It seems to be, you say that a lot, Mr. Ian. That's because it has to happen on every problem. So what do you do with the 5? You put it under the 8. So the first thing you got to do is get a 1 in front of this person. You got to get a 1 in front of that person. So I did, right? There's a 1 right there. Now I take the log of both sides. Now that, my calculator will tell me exactly what that is. But I don't have a calculator, right? I don't have one of these. I can't go, hey, calculator, let's see, what's the natural log of 8 divided by 5? And go, oh, yeah, that's 0.47003629. No, no, you can't do that. You don't have a calculator. You're cheating. Oh, no, no, I've got the log of 8/5 memorized. No, you don't. My point is, that's a number, right? It's 0.47 with a bunch of zeros. It's a number. Now, what do I do? Well, look right here. Log, power, power, front. That's a number. Hey, you know what funny thing? So's that. That's a number. Now, you don't go ask your calculator what it is. We don't have a calculator. So you go like this. In Algebra 1, my teacher said, if I want to make a number go away, I should divide by it. Hey, you know, funny thing, there's a 3. We should divide by that too. Okay. There's your answer. That's your answer. Now, I don't know what number that is, but if you write some decimal down on the test, I'm going to be pretty sure you cheated. Oh, no, no, I did it in my head. Look at you go, kid, go. See, these are better than the log ones. They're better because we just end up with answers that look like this. We don't have to figure out what they are. All right, well, look at 41. 3 to the 1 minus 2x equals 4 to the x. What number's right there? 1. What number's right there? 1. We'll take the log of both sides. The reason we take the log of both sides is so we can move those down. That's why. So look what we have. Now you know the distributive property. Now I'm going to change colors. Those are your variables. You got to get them on the same side. Isn't that what we taught you in Algebra 1? Get the variables on the same side. Mr. Rennie, that's very scary looking. I agree. I agree that is very scary looking. I agree. But you can do the arithmetic. You can do this. You can do this. You can move this over here. It becomes positive. You can do that. It's scary looking. I got you on that, man. I got you. But you can do it. Now, you have two x's. You know how to make two x's into one x. You factor it out. I get it. It doesn't look good. You know how to make this go to that side. You divide. That's your answer. Right? You show that off to your little brother, your little sister, they're impressed. It's just algebra, right? If we turned that into a decimal and that into a decimal and that into a decimal, it's just algebra 1. So this is what we do on these problems every single time, by the way. Every time. Like, look, let's look at another. Bless you. My dog's here. So let's look at 45, right? I'll highlight the ones that I've done. And maybe I'll make, because we're running out of time here in class, maybe I'll make a video and I'll do the rest of these and put it up. We'll see how far we get. Let's look at 45. 45 says 1.2 to the x equals 0.5 to the minus x. We're going to take the log of both sides. Then we're going to move this down. Now we know how to make two x's into one x. We got to move them on the other side. And we know how to make two x's one x. We have to divide. Factor. And now we divide by that. But you know what? Fractions where the numerator is 0, and you're done. Now you can check that to see if it works, right? Does 1.2 to the 0? Well, that's 1. Okay. What about 0.5 to the 0? No, that's 1 too. Hey, look at that, it worked. Okay, this is what we do. We take the log, and then it looks ugly. It's not ugly, it looks ugly, right? It's 2020, we don't call things ugly. Well, we got time for another one. Let's do another one. Let's look at 57. What's going on there? What's on the next page? Now, I don't know how many of you had Mrs. Rainier, and I don't know how many of you didn't have Mrs. Rainier, but she's upset with you. She's not, because she did like this one time last year, but she's hoping maybe one of you remembered. She's hoping one of you remembered. Because you had one of these in your Algebra 2 book. I think you had 2 of these in your whole book. It's got a really cool trick to it. It's the kind of stuff in Algebra 2 you would have thought was cool. Now you're at pre-calc, you're like, oh, that's cool. Look, 2 squared to the x is the same as 2 to the x squared. Power to a power, you multiply. Now I'm going to come over here and I'm going to go like this. Now I'm going to put an A right here and an A right there. And look what I get. Look at that, it turned into a quadratic. It turned into a quadratic. It turned into a quadratic. Now, if this was a good problem, a nice problem, this would factor. Okay, this doesn't factor. Michael was really mean on problem 57. He was really mean. You have to use a quadratic formula to solve that. Right? And when you do, look what happens. B squared is 16 minus 4 times A times C all over 2A. Look under there. Look at your discriminant. That's negative. This has no solution. The discriminant is negative. So he wanted you to do all of this, but he wanted you to see it had no solutions. Right? Now, that's mean, right? I mean, that's kind of mean. So I think instead of us, making a voodoo doll of Michael and sticking pins in it, which, I mean, if this was the problem he gave us, he would probably deserve a voodoo doll, because that's kind of mean. But instead, let's go like this. Let's go like this. Let's look at what Michael asked us to do. Okay, let's look at what Michael asked us to do. Because this is what he wrote in the book, right? This is what he wrote. So let's pay attention to what Michael asked. Michael said, raise 4 to a power. Okay, the graph of 4 to a power looks like this. Right, this is y equals 4 to the x. Do you notice that there are no negatives here? No negatives. So 4 to a power is always positive. And then Michael said multiply by 3. Positive 3. So this is a positive number. Then Michael said raise 2 to a power. Well, funny thing, if I erase this, I can act like that's a graph of 2 to the x. And I can say, do you notice there are no negatives? And then Michael said multiply by positive 4. Well, positive times positive, this is positive. So Michael said, add two positive numbers together. And then while you're at it, add positive 8. So positive number plus positive number plus positive number. And oh yeah, by the way, I want you to equal 0. Yeah, see, that's not going to happen. This has no solutions. You should have had no solutions when you wrote it down, right? If you were engaged with the question, you realized it had no solutions when you wrote it down. That's what Michael wanted you to do, right? Because he's always looking out for you. He's not torturing you. He's always looking out for you. He wanted you to write it down and go, thank you, Michael. It's number 57. I'm tired. I've been doing this for a long time. That has no solutions. That's what Michael wanted you to do. And he wanted us to engage with the problems as we write them down. But don't get mad at me about number 57. I didn't write the book. If you got hostility about that, take it out on Michael. All right. So I have not done number 43 and number 59. So I will record a short video with 43 and 59 on it. And then I will post this video for second period and sixth period today, this afternoon. All right. Then you can use those to answer all your questions.